Hello everyone. In this video we are going to discuss about Bombay blood group or H-antigen homozygous recessive blood group. So what is mean by Bombay blood group? It is a rare kind of phenotype, rare blood phenotype in which the surface of RBCs of blood does not express any H-antigen or H-antigen is absent. So as we all know that H-antigen is precursor for antigen A and as well as antigen B. And if the H-antigen is unmodified, then it refers to O blood group. So why is it called as Bombay blood group? It is so because the Bombay phenotype was first discovered in the city Bombay of India. Now the city is called as Mumbai and it is discovered in the year 1952. Who discovered Bombay blood group? It was discovered by Dr. Y.M. Bende. So the first individual to have Bombay blood group had reacted to all the blood transfusion. In the sense, he reacted to the blood group A, blood group B, blood group AB and as well as blood group O. Because in the blood group of Bombay phenotype, it does not contain any kind of antigens like antigen A, antigen B and as well as antigen H. These three antigens are absent. Next, what is the incidence of Bombay blood group? It is 0.0004% per million. In the sense, it is 4 per million or 1 per 250,000 members. And in case of Mumbai locals or Bombay locals, it is 0.01%. In the sense, it is 1 in 10,000 members of inhabitants. Next, why do H antigen is absent in Bombay phenotype individual? So it is because the point mutation happened in the gene fucosyl transferase, that is FUT1, and this gene is present on chromosome number 19. So what is the full form of this? It is fucosyl transferase. As due to this mutation, the H antigen is not synthesized. Next, let's move on to the genetics of Bombay phenotype and how the progeny gets Bombay phenotype. So, in case of heterozygous dominant parents, both the parents are heterozygous dominant. So, let's see the cross. It is homozygous dominant and it is heterozygous dominant and it is also heterozygous dominant, whereas in case of the last one, it is homozygous recessive. So, homozygous recessive is Bombay phenotype positive. So 1 in 4 progeny will get Bombay phenotype. And in case of heterozygous dominant one parent and homozygous recessive another parent, let's see the cross. It is heterozygous dominant and homozygous recessive and homozygous recessive. In case of this cross, there is 50% of the progeny who will get Bombay phenotype. So the chance is 2 in 4 of the progeny will get Bombay phenotype positive. And whereas in case of both the parents are homozygous recessive, then the cross will be all of them will get Bombay phenotype. 4 of 4 will get Bombay phenotype or H-antigen homozygous recessive. Next, what makes Bombay blood group different from other ABO blood groups? So, the minimum requirements for the H-antigenicity is the terminal disaccharide, fucose, galactose, and the fucose must have alpha 1 2 linkage. So, when the H antigen is attached to the or bind to the substance N-acetyl galactosamine, then it is called antigen A. And in case of when the H antigen binds to galactose, then it becomes antigen B. And when the H antigen is unmodified, remains same, then it is called O blood group. In the sense, H antigen is unmodifiedly present. And when the H antigen is absent, then it is called Bombay phenotype or Bombay blood group or H antigen homozygous recessive, where H antigen is absent. So let's see the table. In case of blood group A, the antigen which is present on the plasma membrane of RBC is A antigen, and the antibodies are anti-B antibodies in the serum, and the blood that can be tolerated is A blood group is tolerated, and as well as blood group O. And whereas in case of B blood group, the antigen which is present on the plasma membrane is B, and the antibodies which are present in the serum is anti-A, and the blood that can be tolerated B as well as O. And in case of blood group AB, antigens present on the RBCs are antigen A and as well as antigen B, and there are no antibodies, and blood that can be tolerated is A, B, AB and as well as O. So the AB blood group is called as universal recipient blood group, and whereas in case of O, there are no antigens. And the antibodies are anti-A antibodies and as well as anti-B antibodies are present in the serum, and the blood that can be tolerated is only O blood group. So O blood group can donate blood to any other blood groups but only accept O blood group. And whereas in case of Bombay phenotype or homozygous recessive phenotype, here there are no antigens, includes H also. In case of blood group A, blood group B, blood group AB and O, along with the AB, there are H antigen present. But in case of Bombay blood group, there is no H antigen present, and the antibodies which are present in the serum are anti-A antibodies, anti-B antibodies and as well as anti-H antibodies. So the blood that can be tolerated is only Bombay phenotype is tolerated. And next, let's see the hemolytic disease of newborn. So in the case of Bombay phenotype positive mother and as well as the fetus is Bombay phenotype negative. So what happens? Theoretically, the maternal blood will produce anti-H antibodies during pregnancy, and these might cause hemolytic disease in the fetus. Hemolytic disease in the sense lysis of RBC. It will reach the fetus circulation and cause the damage of the lysis of RBC. But practically, hemolytic disease of newborn is not described yet. So the reason behind this is it can be because of the rarity of Bombay blood group. As it is rare phenotype, it is not described yet. And the next reason is when a blood transfusion is wrongly done or the wrong blood group is transfused, then the immune reaction triggers the immune system and it will produce antibodies which belongs to the class IgM. And these antibodies cannot be cross the placental blood vessels to reach the bloodstream of fetus. I repeat once again, these antibodies, as they are big in size, they cannot pass through micro circulation of placental blood vessels into the bloodstream of fetus. So, the bloodstream of fetus cannot receive IgM antibodies, so the fetus is not affected. And note, Bombay phenotype individuals may have or possess alleles for either or both of the antigen A and as well as antigen B without being able to express. This means a Bombay phenotype individual may contain genes, in the sense variants of gene is alleles antigen A and as well as antigen B. They may contain this antigen A and antigen B expressing alleles, but they cannot express antigen A or antigen B on their RBCs. This is because the reason behind this is H-antigen is precursor for antigen A and as well as antigen B. So, if antigen A and antigen B should be expressed, then H-antigen is must and should. But in case of Bombay phenotype, there is no H-antigen present. So, the RBCs, the surface of the RBCs cannot express antigen A and as well as antigen B. So, this is all I got for this video. I hope you like this video. If you really like this video, please do like and share my channel. And if you have any suggestions, please do drop in the comment box. Thank you.